Hello guys, welcome to Science and Tech series, and this session is our ninth session. Not ninth, sorry guys. Yeah, this is tenth, our tenth session related to the Science and Tech, and this is very small video, the small video like and around 50 minutes. Okay, and today we are going to learn some important terms and terminologies related to the sun and what are the nuclear fusion and sun structure, what is that. Okay, let's go. Today become an interesting topic for today. Okay, before that we are going to learn some distance in the solar system. What are some distance means earth to sun, moon, like that. Okay, the distance, let's go to learn what is the distance between Earth and the Sun, that is 150 kilometer. We know that is approximately 1 astronomical unit. We called this is 150 million kilometer. We called 1 astronomical unit. Okay. Definition here, that is 1 astronomical unit. It is average distance between the Sun and Earth, that only. That is 1 astronomical unit is equal to 149.6 million kilometer approximately, that is 150 million kilometer only. It is time taken by the sunlight. Okay, from the sun to the sun ray fall in the earth. It will take 8 minutes 20 seconds. 8 minutes 20 seconds to fall light in the earth. Wow, this is compared to huge time, yeah? Because of the light speed is 3 into 10 power 8. Here light speed also is 3 into 10 power 8 minute per second. Here size of the our sun. Radius comparison. Comparing with the radius. Earth radius is 6,400 kilometer. Sun radius is 6,96,000 kilometer, guys. Radius, I am not talking about diameter, just half side of the earth or sun. Radius, okay. Nearly 1 knot times earth radius. Earth radius. 1 knot times need to be earth radius to fulfill the sun's earth radius. Here volume. Okay, volume means how much of the earth we can fit in the sun. That will 13 lakh earth we can fit in that. And yeah, here some approximation is done. Okay, sun to Venus distance is 100 million kilometer. From earth to sun is 150 kilometer, you know. And earth Venus, that is closest approximately 50 million kilometer. Earth to Venus, that is 50 million kilometer. Okay, that's why it is 100 million kilometer. Earth to Venus just 50 million kilometer is there. Both combining we can get our some now structure of the sun. Okay, now we are entering to the know about the sun. Some major 6 layer is there of sun. Okay, first outer layer is the coronal. Let's go to from inside to the outside. Okay, from inside to the outside. First one is core, that is 50 million degrees Celsius nuclear fusion. Nuclear fusion, guy, just remember this fusion word. Okay, not fusion, that is fusion. Nuclear fusion happen in the core. Okay, that is 50 million degrees Celsius. Radiative zone. Second zone is the radiative zone. Millions of degrees Celsius. Energy transfer via radiation. Here, energy will transfer via radiation. And next, convection zone. Third layer is the convection zone from the center. Energy move via plasma convection current. Here, energy will move like a plasma convection. Next, photosphere. 6,700 degrees Celsius to 3,700 degrees Celsius lowest temperature. Here, photosphere, right? Here, low temperature is there compared to here and here. And chromosphere now. Here, surprisingly, rise temperature will rise 3,700 degrees Celsius to 7,700 degrees Celsius. In this zone, chromosphere, this zone, here temperature will suddenly rise. Coronal, outermost layer, it is 1 to 2 million degrees Celsius, extremely very hot. The outer surface of the sun is very, very extremely hot. Now, nuclear fusion. Nuclear fusion is happen means nuclear fusion process will be there in our sun. Okay, because of the nuclear fusion only sun will shine. In that nuclear fusion reaction, in that four nuclei, four hydrogen nuclei. Just remember that four hydrogen nuclei. It in that reaction it will gives one helium nucleus and most of the energy compared to the here mass of the helium become less. Mm, because to compensate the mass of both sides the extra energy will come. Okay, why will energy means to compensate the mass of right side. Now comparison between the fusion and fission. Okay, the nuclear fusion and nuclear fission, it is happen in the nuclear reactor. Okay, remember guys, it is happen in the nuclear reactor. It is nuclear fusion in the sun. It is just you what is the process? It's small nuclei will combine. Small nuclei will combine form a big atom. Here, what is it will split. The heavy nucleus will split. And location, it happen in sun and star. It happen in commercial nuclear reactor. See guys, it is happening in commercial reactor, nuclear reactor. It fuel hydrogen to the helium, and it is its fuel is for platinum and uranium. It requires extremely high temperature and low operational temperature. Control difficult to sustain and control. It is commercially controlled and used worldwide. What is plasma and solar wind here? Plasma means a million of degrees atoms cannot remain neutral and electrons separate completely from nuclei, resulting in a superpositive ions and free electrons. It is a plasma. Okay, guys. Now, what is the solar wind? That solar wind means after the last layer of the coronal to sun, that is corona, right? From that corona, the most of continuous flow of charged particle will flow in the wind, right? That is the solar wind. In that protons, electrons and alpha particle will be there in a charged particle of the solar wind. In solar wind, what are the composition is have alpha particle is there, electron is there, proton is there. Okay guys, just remember proton, electron and alpha particle will be present in solar winds and it will continuously flow in the space. Okay, but the why it occurs? Because of the extreme high coronal temperature and cause the ultra high pressure. Because of that, and gravity can't hold that particle and letting them escape space. That's it.